Alrighty guys, so looking at 11-3, we are talking about different shapes of your data. So in our data, when we look at a shape of our data, we are either going to have a normal distribution or a skewed distribution or skewed data. So normal is going to just look like a perfect curve. It is very symmetrical, looking very nice. Skewed is going to be kind of leaning to one side or the other. It's not going to have that perfect symmetry like normal distribution will have. And there's two different types of skews that we could have. We could have skewed left. Now, when you're looking at this, I always get it confused and I like to look at the data. But in order to find which way something is skewed, what you want to look for is what's called the tail. So where your data gets kind of really small is where your tail is at. Same thing on this other one. We have our data getting kind of small over here where we have another tail. So wherever your tail is at, the left or the right side, that is which way your data is going to be skewed. So on that first one, that blue one, our tail was on the left, meaning our data was skewed left. On that kind of greenish, yellowish color one, the bottom one, our tail was on the right, so we had skewed right. So let's look at some examples together. So if we are looking at some histograms, same kind of concept, no matter what kind of data we're looking at. So it says the histograms below show the weights of all dogs entered into two different categories of dog show. Consider each data, what inferences can be made about the shape of the data. So looking at this first one, the orange one, I like to kind of draw my shape of my data to kind of see what's happening. Now, on this one, you may say, hey, there's a little bit of a tail on that right side. I would kind of say this first one is a normal distribution. It's not perfectly normal, because remember, nothing's going to be perfectly normal when you're looking at data, but it's pretty darn close. So for that first one, I would say we have a normal distribution. On the second one, if I draw what's happening here, I can really see that that tail is happening on that right side. So for that blue one, we would say we have a skewed right. So it wanted us to make some assumptions about these two different categories of dogs. So looking at that first one, it looks like we have anywhere from 10-pound dogs to 80-pound dogs. So I would say that first category really has a wide range of types of dogs that it has in it. In the next one, we have a lot of dogs more kind of towards the smaller end, from 0 to maybe like 40 pounds. I know we have some that are a little bigger than that, but most of the dogs in that blue section were all kind of smaller. So what we can come up with from looking at these two different types of data is in that first category of dogs, we can see that the data was pretty far spread across all different weights. So we could say down below that that first category data was spread evenly across different weights. For the second one, we would say that the data was more smaller weighted dogs. All right, looking at this next example, we have 3 different types of data that we're comparing. So it says Jennifer is considering job offers from 3 different school districts. The histograms show the salary ranges for similar positions in each district. Identify the shape of each distribution. What do the shapes of the data tell Jennifer about the teacher salaries in each district? So let's look at our different shapes. On this first one, if we kind of draw what's happening, I would say that that's pretty normal. It's not perfect, but it's pretty normally distributed throughout that. And then the next one, it looks like if we draw our curve, we have a tail over here on the right. So for this one, I would say we are skewed right. And then the last one, we are having a tail over here on the left. So for the last one, I would say we are skewed left. So we have 3 different types looking at what's happening. So on each of these, they're telling us how many people in those positions have a salary within each range. So for example, if we kind of look at each one for this first school district, this column says that 6 people said they had a salary within $50,000 to $59,000. Okay, and then on this one, they had 3 people say they had $60,000 to $69,000. So that's how we're reading those graphs. So for this first one, it looks like most of the people are within this 60. Honestly, we could say most people are within these 3 columns. So most people make $40,000 to $69,000. I should put those zeros in there. Let's actually fix that. $40,000 to $69,000 for this first one. For the second one, it looks like most people are making within these 3 bars, which is most make $30,000 to about $59,000. And then the last one, most people, it looks like, are making within these 2 bars right here, which means that most are making, between $60,000 and $79,000. So looking at just the salaries, we want the job that uses our skills but makes the better amount of money for what we're doing. It said all 3 of these jobs were doing the same thing but making different salaries. Now, there are people within these that are making outside of the ranges that we said, but most of the people that we're looking at is kind of what we care about. So this one random person over here that's making $80,000 to $90,000, cool, but that's not where most of the people at that school district are working. So we want to find the job where most people are making the most money. So if we look at those, we have a $40,000 to $69,000, $30,000 to $59,000, and a $60,000 to $79,000. So what I would say is school district 3 is the place I want to work, because they are making the most amount of money, or most people are making in the higher range of salaries within these 3 school districts. Okay, one more thing I did want to mention. This is not in your notes packet, but we talked about most of our shapes within histograms or a curve of some sort, where we have a tail on one side, and that's where we are skewed to. If we have a tail on the right side, we are skewed to the right. That same thing is going to apply when you're looking at a box and whisker plot. So if you have a whisker that is longer, or a tail that's longer on the left side, your box and whisker plot is also going to be skewed left. If you have even whiskers, your data is going to be symmetric, or we called it normal. And then if you have a tail or a longer whisker on the right, your data is going to be skewed right for that box and whisker plot. Same things apply, same rules.